Good day, everyone. I am CDT.RASING Brian from MT to Bravo, and for today's topic, we will be doing some chart work exercises, which tackles about allowing for the leeway or the wind and set of current on ship's course and speed. For here, we can see an example question from 1500 hours. A ship sails at 6 knots, steering a course of 230 degrees through. So, a current is setting 120 degrees through at a rate of 1.4 knots. So, we need to determine such by plotting this following. The first one would be the DR position at 1630 hours, and an estimated position at 1630 hours as a result of the current, and we would be finding the course made good or the CMG, and also the speed made good, which is the SMG. So let's summarize this question. So on the side here, so it says that it's 1500 hours. Ship sails at 6 knots, steering a course of 223 degrees through. So let's assume that this is a 1500 position. This is a fixed position. That is, it's an accurately known position. So the fixed positions are denoted by a circle and a dot in the middle. The dot is right on the position of the ship. From 1500 hours, let's sail the ship at about 6 knots on a course of 230 degrees. So if we are doing 6 knots, so in 1.5, as the vessel should have done about 9 miles all. So right, so you will draw a line 230 degrees in the bearing of 230 degrees, and for a distance of 9 nautical miles, and you can measure 9 nautical miles on your compass and draw it like an arc of a position circle that is the course and to be steered. So because the ship speed is 6 knots and it travels about 9 arc miles in 1.5 hours, just draw it like an arc of a position. The arc and the coastal steering line, whatever they intersect, that is the dead reckoning position. They don't denote it by a cross or a plus sign. So now, so also given to you, the question was that the current is setting 120 degrees through at a rate of 1.4 knots, and you have to determine the estimated position, which takes into account the effect of the current, so it is more accurate than the the dead reckoning position. And as a result of the current, and you have to find the course made good and speed made good. So the current speed is 1.4 knots an hour in 1.5 hours. So the rate of the current will result in a drift of about 2.1 nautical miles. So it's 1.4 knots per hour. So in 1.5 hour, the current would result in a drift of 2.1 nautical miles. So let's draw the F current here. So the current has been drawn in the direction of 120 degrees through. So current is always drawn pointing towards the direction where it is going. So the 3 arrows denote the direction of the current, and they are always drawn towards the direction in which the current is going. So you will draw it for a distance of 2.1 nautical miles because we are making this triangle, or excuse, these vectors are all for about 1.5, so not for 1 hour but 1.5 hour. Not for 1 hour, okay, but for 1.5 hour. So if we say that the time of steaming was 1.5 hour based on the current rate, which is the current speed per hour, the drift is 2.1 nautical mile. So at the end of 2.1 nautical miles, you will then join the estimated position that you C. So, at the end of the 2.1 nautical miles on your current vector is your estimatable position. Estimate position is denoted by a phase triangle with a circle in the middle, and that is more accurate than the dead reckoning position because it takes into account the effects of current. Now, from the fifth triangle, join the 1500 position, and that will give you the course made good and the speed made good. In the last 1.5 hours now of course, course made good in this case becomes 216 degrees through, so that means that although you intended to steer the vessel on the right course of 230 degrees through, because of the effect of current, your vessel actually steered a course of 216 degrees. Now remember, here we have not counteracted for the current. We'll do that in the next slide.
So in this case, this becomes distance covered in this case.
So,
and I work it out separately is about 8.5 nautical miles, but
216 degrees.
time of 1.5 hours, so the resultant speed
to the course
made good is
denoted by a single arrow,
knots,
and the
but
course made good is
5.7
denoted by
knots per
double
hour.
arrows.
So the resultant speed made good of the ship because of the effect of current
0.5 nautical miles, but that was in 1.5
nautical
hour,
miles
and
because
the
you
ship's
did
speed
8.5 miles
in 1 hour,
1.5
there
hour.
will be
You should,
5.7 nautical
about 9
miles.
nautical
Not
miles
so
of
all
where,
you do
we're
is just
going at the
divide
original speed of
8.5
6 knots,
by
but
1.5, you will get the answer. So this is only taking into account that the effect of the current. Now let's understand how the effect of the wind is also taken into account. So I'll just show you here the animation, how this is actually how the vessel proceeded. So the vessel did not proceed on its original course as intended and did not reach the dead reckoning position, but it reached the estimated position because it was affected by the current. So the vector triangle is for 1.5 hour. Remember, everything was taken into account for 1/2, so you can take one for one side of the triangle for 1 hour and the other two for 1.5 hour, or vice versa. So you have to draw everything for 1/2 hours because the vessel's steaming time was 1.5 hours, and the current that you draw and the speed made good and the course made good that you calculate is all for 1.5 hour. You have to remember this is for you to keep your vector triangle constant. It is for 1 hour. That's fine, but if the question dictates that you have to draw it for 1.5 hour or some other hours, that's what you have to do.
So let's take into account another example here, and this example is taking about estimated position 1 and estimated position 2. These are those positions when leeway and the current said that is the direction of the current are both present. So when you have to take into account the effect of the wind and the current, remember, always allow for the leeway. So the way I was taught when this allows leave, this L is very prominent. So when you are allowing for, you must allow for this leeway first and then the current. But when you counteract, I'll show you what happens when then. Alright, so when you allow for it, always allow for the effect of the wind, that is leeway first, and then allow for the effect of the current, and this gives you to estimate positions, which are known as estimated position 1 and estimated position 2, EP2 or EP1. So estimated position 1 is a result of the effect of wind, and estimated position 2 will be the position of the vessel, so due to the effect of the current. Now EP1 for leeway and EP2 for leeway and set. So this all works together at this question. So we take the similar example, we take the same question again. We know the accurately known position of the vessel at about 1500 hours. The vessel was intending to go on a course of 230 degrees through for 1.5 hours at 6 nautical miles per hour. So again, you will do the same thing. You will draw the course of 230 degrees through. You will draw 9 nautical miles because that would be the estimated position. I mean, estimated speed rather of the vessel in the next 1.5. So it was based on the fact that it's doing 6 knots per hour. And then at the end of the 9 nautical miles, you will draw a plus sign which will give you the dead reckoning position. That's the dead reckoning position. But first, we have to also take into account, now after the dead reckoning position, you have to take into account the current and the leeway. But like I said, if there is both current and leeway, you must account the leeway first. Now in this case, there is a northwesterly wind causing a leeway of 10 degrees. So that means it's coming from let's say it's from the top of the screen. So it's pushing the vessel towards the bottom of the screen, or the head towards the right head corner of the screen. So the screen, that's why when the north is the northwesterly wind, westerly wind is coming, the vessel is being pushed to the right of the screen. So in the 10-degree course has been drawn towards the right of the screen, if I can explain it right. So always allow for the leeway first of 10 degrees, pushing your vessel on the left of 230 degrees, which would be 220 degrees. So the resultant course then becomes 220. You draw 9 nautical miles again, and that becomes an estimated position 1 from estimated position 1. Draw the current direction, or the set of the current. It will be drawn similar to the previous one here, where you draw it towards 120 degrees because that's where the current is going to. Currents are always drawn in a direction where they are going to. The 3 arrows will be pointing towards the direction of the current draw. And the drift of the current will be again 2.1 nautical miles based on the fact that its rate is 1.4 knots per hour. Alright, so once you draw it for 2.1 nautical miles, join the 1500 position to the fish first triangle, which is estimated position 2 at 1630 and then that will give you your course made good as well as your speed made good. For the last one and 1.5 so you can measure this distance and then divide it by 1.5 knot, or not 11.5, that's right, and it will give you the speed made good of the vessel. The vessel in an hourly rate. Alright, so you measure the whole distance. That will be this distance covered in the last 1.5 hours. It will not be the speed of the vessel in 1 hour as we saw in the previous slides. Alright, so the vector triangle will again be 1.5 hour in this case, and not more or less. So because everything was assumed for a steaming time, 1.5 hours. So guys, I hope this that would be all. I hope this video helps and hope you understand the concept of getting the course made good and the speed made good, and I hope you learn more. That would be all for me today. I am Cadet.RASING Brian from BSMT to Bravo, and that would be all for this video. Thank you.